Good evening, everyone. I'm going to start the call in just a few seconds here. It looks like all of our team has been assembled. You know, we've got a great call for you tonight. Actually, I think what's going to be one of our more significant scientific advisory board member calls, because this call is actually going to get right at the root or the heart of the Vasayo story. You're going to learn a lot about liposomes and phospholipids today, and we're going to be introducing you to one of our newest scientific advisory board members. The order of the call for tonight is we're going to be starting out with Dr. Stephen Sabo. I'm going to be introducing him briefly, and then he's going to be talking about kind of the, what the supplement industry has been like in the past, a little history behind that, the poor absorption, lack of clinical studies, things like that. And then we're going to go hear from Dr. James Baker, and he's going to talk to us a little bit about the invention of the liposome. We're going to lead this call right through a history of the liposomes up until even current clinical studies and science behind liposomes, and then we'll cover even the future of liposome technology as well. So let me start off the call by welcoming you all, and I'm going to introduce Dr. Sabo right now. He's a graduate of Chicago Medical School. He's currently working as an emergency physician at, if I can get this right, I believe it's the Good Samaritan Regional Medical Center there is it in New York, Dr. Sabo? Are you across the border or?
Yes, I live in New Jersey and I work over the border in New York, yes.
Okay, yeah, I'm pretty sure the medical center was in New York. Anyway, pleased to have you on the call tonight, and why don't you start us off with a little bit of a history of the dietary supplement industry.
Sure, Tracy. I'm happy to be here, everybody. As Tracy said, my name is Dr. Steve Sabo, and thank you, Dallin and Daniel and Dan and everybody for the honor of being on this wonderful scientific advisory board. So as Tracy said, I'm going to lead it off kind of with the introduction. Going to talk about a few things leading into the actual meat and potatoes of the call about liposomes. So, guys, there are lots of problems with vitamins out there today. There's poor absorption, there's poor quality, and there are contaminants. And I'm going to touch a little bit on those topics. First, have you guys ever heard the saying, all you get from vitamins is expensive urine? And you know what, guys? That's really true, because vitamins are just poorly absorbed. And there's several factors out there that actually affect absorption. And there's the quality of the vitamin itself. And when the vitamin gets digested in the digestive tract, it disintegrates. And so the vitamins have to be broken down first in order to be absorbed. There actually was an interesting study where they correlated disintegration time and vitamin C availability, bioavailability, and it actually showed that the tablets that broke apart kind of broke apart either too quickly or not quickly enough, and therefore weren't absorbed well. And they found that the optimal time for breaking down or disintegrating the tablets was actually about 90 minutes. The other problems here with the vitamins, many vitamins, they contain binders or fillers to help them stick together. And not only does that lead to poor disintegration, but a lot of them can be contaminants and may be quite harmful to you. Let's talk a little bit more about quality here, quality of vitamins, and it really varies between both the vitamins and also in the country that the vitamin is produced. There's variability in different vitamins, and the saying is not all vitamins are created equal, because vitamins, the same vitamin C vitamin, for example, made with between different companies, different absorption rates, different quality. And when you talk about countries, you see each country obviously has their different regulations, and so the vitamins created in each of the countries are also going to be different. And you also have to throw on top of that, those that are made in the United States, you have to remember again that supplements are not regulated by the Food and Drug Administration. So there's not a lot of quality controls in a lot of the vitamin companies out there. You know, I read a story actually about this nutrition guru. I forgot his name, but he started his own supplement company. He took his own product. He developed severe fatigue and pain, and he went to a doctor, and the doctor did his vitamin D level, and it was sky high. And so he ended up in a twist. He sued his own company because it turned out the company mistakenly put 1,000 times the amount of vitamin D into the product that was on the label. And so he was getting vitamin D toxicity. And other people started complaining, and some of them developed kidney failure. There was a study in 2013 regarding the potency of vitamin D. And first, it's important to know that there's a standard for potency. It's called the USP standard, and it's basically between 90 and 120%. So if, for example, there's supposed to be 100 milligrams on the label of a substance, acceptable would be from 90 to 120. So they did this study in 2013 of vitamin D, and they found that in the different pill bottles that they tested, the potency ranged from way down 9% all the way up to 146%. So you see, even comparing vitamin C bottles, even that says a certain amount on the label, you're not getting what it says. And interestingly enough, even today, companies actually only voluntarily have to comply to this certification of potency. Shelf life. Shelf life is another factor with quality of vitamins. Keep in mind that substances may be added to vitamins only to increase shelf life. Again, substances that may be harmful. You know, the other thing with vitamins is that they actually can cause liver damage and kidney damage. First, liver. 2014, there was a study I read that was called Liver Injury from Herbals and Dietary Supplements. And they broke the groups into bodybuilding and non-bodybuilding, because we all know that bodybuilders, they use supplements. They use steroids, they use other supplements. And no surprise, both groups actually had increased liver injury. But the interesting thing was that the non-bodybuilding group actually had a higher incidence of liver injury. And as far as the kidney, 2007, there was a review of supplement-induced renal dysfunction, which means supplement-induced kidney problems. And most of this data in this study came from case reports. So there really wasn't a lot of data or cases on each of the supplements that they tested. And they also decided that it was kind of difficult to determine specific supplements because a lot are really put in combination. And the other thing that was interesting, they felt that the kidney injury was actually underreported because in the supplement industry, it's not mandatory to report problems with supplements as it is with medications. If you have a medication or a drug reaction, it's mandatory to report that. And the last topic that I want to talk about here is the historical problems. Tracy asked me to talk about the historical problem with supplements and why physicians are skeptical of supplements. And you know, when I think of skeptical doctors, you guys that don't know doctors, first, you realize we're all doctors are skeptical, period, of supplements, of new treatments, of any of this stuff. And I just think of my own family, my brother, the neurosurgeon, and my father, the retired thoracic surgeon, and the fact that I was brought up in a household where nobody took supplements. And I started thinking about that, and I came up with 3 reasons here. And one of the reasons is, I think, a lack of knowledge. Back when I went to medical school, we weren't taught about supplements. Also, there's a perception, as we've just talked about, of poor quality and poor absorption. And then in addition to that, doctors question, again, we question everything, but lots of doctors question the actual effectiveness of supplements. So, Tracy, I'm going to wrap it up here and turn it back to you. So my question to you is, How can we solve these problems with supplements?
Hey, thank you very much, Dr. Sabo. And, it's exactly the battle that I've been fighting my entire career in the dietary supplement industry, is trying to bring more science to our industry, fighting for standardization of herbs, fighting for regulations and standardization of the industry. And, believe it or not, we have come a long way. The Dietary Supplement Health and Education Act was passed in 1996. It wasn't funded until just recently, though, to where regulations are finally being enforced as far as GMP certification and whatnot. But when it comes to delivery and absorption, it always has been a problem in our industry, and finding that optimal delivery method has always been a problem. I mean, since even in the early 90s when I started formulating, I was focusing on enzyme and enzyme delivery systems and increasing absorption ratios that way, because, all of the, at that time, the liposomes and nanotechnology was all wrapped up in patents and owned by Big Pharma. And that takes us to our next presenter, Dr. James Baker. He's going to tell us a little bit about liposome technology and, the invention of it and how it was originally used and leading up into today's time. But let me introduce Dr. James Baker to everyone. He is on our Scientific Medical Advisory Board as well. He's currently the president of medical staff at Northwest Arkansas Rehabilitation Center. He received his doctorate from Oklahoma State University. He's a huge contributor to our cause. He's got a lot of experience with supplements, a lot of experience treating his patients. Anyway, I'm super pleased to introduce, for those who are new, Dr. James Baker. James, are you on the call?
Yes, Tracy, I'm here.
Great. All right. Well, why don't you tell us a little bit about liposomes, what you've got to share with us here.
Thank you, Tracy. Thank you very much. Thank you for asking me to talk a little bit on the history and some of the development of this liposomal technology we'll talk about. One thing I need to tell you, though, Tracy, is as I've read a lot of articles on liposomes preparing for this, I am realizing that the complexity of the lab techniques used to produce and improve and to prepare these molecules for their unique transport qualities is just remarkable. So I'm just fascinated by it. But with that said, let's start by just a little bit of a definition of the way the word itself, liposomes. Lipo means a fat or a healthy fat. Soma or somes means body. Basically, these are simple microscopic vesicles or bubble-like spheres in which there's a watery substance that is entirely enclosed in a membrane of lipids, which means healthy fat molecules, okay? Now, the way I did this is I wanted to break the history of liposomes down just a little bit into 3 generations or eras. The first one, of course, being the genesis of this science, from 1961 to 1975. The liposomes themselves were originally discovered by Dr. Alec Bangham, who was a British hematologist at Cambridge. In 1965, he was joined by Dr. Gerald Weissman, who was an American physician and scientist, very well known. Up until not too awfully long ago, he was still professor emeritus at New York University. When the chemical characteristics were discovered, methods were developed to form these multi-layer bubbles. They also discovered during this time that the membranes of the bubbles were almost identical to the biological membranes on the cells throughout our bodies. Originally, they found this on smears of egg phospholipids, where they added a water medium to this, and spontaneously this intricate bubble-like structure formed. Then they went on to look more into the techniques of storing other molecules inside of these lipid bubbles, depending on their chemical makeup. I like to refer to the next section as like the Middle Ages or the Middle Era, from 1975 to 1985. Liposomes were being re-engineered during that time to be more useful in the medical field specifically. Detailed lab work was underway to learn how to maintain better and longer stability of these molecules as they circulate in our body's harsh environment. Now they are more ideal for delivering pharmaceutical drugs or even DNA, directly to target cells, some of them referred to now as stealth liposomes. Due to the various drug toxicities, this research was geared toward getting these drugs to the cells they need to get to with less toxicity and perhaps even higher concentrations, particularly in the chemotherapy situation. It was during this time that technology for making liposomes smaller and more efficient was being developed, as well as looking at other compounds that might be carried inside of these little bubbles. In the modern era of liposome research, from 1985 all the way through the present, liposomes are now being used successfully in various scientific disciplines, including mathematics, theoretical physics, biophysics, biochemistry, even colloidal science, pharmaceuticals, obviously, for cancer treatment, even in the cosmetic area, treatment of parasites, fungus, and other infections, maybe in the vaccines will be used with liposomes, and of course, nutritional science that we're talking about. The first liposomal drug formulation in the United States was the anti-cancer drug called doxorubicin. It was encapsulated in a liposome, and it was approved by the FDA in 1995 to treat what's called Kaposi sarcoma, which is one of the deadly situations that patients with HIV get into. Since the 1990s, we have learned that in designing these liposomes in the lab, their properties are determined by several factors, and these variables have to be very carefully controlled. I'm only going to mention a few of them. It's quite complex as you go through these. But some of the techniques that need to be controlled very closely, perhaps, is even the water temperature that is used. Also, the choices of phospholipids that are used, and there are a lot of them out there to choose from today. The nature and characteristics of the drug or the nutrient that it will be carrying. Also, we need to figure out how to add kinetic energy sources, such as what is called sonication, to help make these bubbles, these liposomes, more efficiently. Sonication is applying sound energy, basically, to the solution. There are sizing techniques to keep these molecules as small and stable as they can be so they can get to our target cells, as we have mentioned before. They've even gone as far as adding other molecules to coat the liposomes, such as polyethylene glycol. That also helps to keep these bubbles stable while circulating through our body to the target cells. Actually, today it's even possible to design liposomes with release rates and timing of release that is programmed to what their application or their use may be, as far as when you're delivering a substance that is inside of these bubbles. A recent article stated that the liposomes that are being made today are more stable and smaller in size, and with high-quality ingredients to put in them, like some of the newer pharmaceuticals, as well as nutraceutical products, they will continue to revolutionize medicine in the years to come, was a statement that was made. Hopefully, after all the talks that everyone's going to hear tonight, those of you listening, as well as myself, can be better equipped to tell others about how Vasayo is delivering valuable nutrients right now into our bodies, really using cutting-edge technology. And if I can't get anything else across in going through a brief history of liposomes, that would be it, is that we are dealing with a cutting-edge technology that's evolving all the time. And some of the remarkable things Tracy has done to help us with our nutrient delivery is just amazing. And hopefully we'll learn more about that as we go. But again, thank everybody for having me on. Tracy, thank you.
Hey, thank you, James. And you know, you mentioned something specific, something that I learned during my schooling in liposomes. They are advancing, and a lot of those advances we see are synthetic advances. And being a purist and a naturalist, you know, I wanted to specifically focus on phospholipids and the many different types of phospholipids that we can choose from. And of course, how do we make those stable and last 18 months or 2 years? And it all boils right down to exactly what you're saying: controlling the pH levels, controlling the water temperature, combining the right phospholipids with the right nutraceutical ingredient. I spent my entire day in the lab today with a couple of other Vasayo employees, and that's where, as we're working on new products and trying to get these phospholipids stable and to taste good and all the things that we have to do to make these products come out, it is a difficult science, and it is a very exact and precise science. And I'm glad you mentioned those phospholipids, because I'm going to be introducing you all to Dr. Lana Galicia now, who's going to teach us more about phospholipids and the natural forms of liposomes. You can actually get polymer liposomes now that are basically made from plastics, and they have time release, and they do target cell specific needs and drug specific needs, and those aren't the type of liposomes that we use in the natural sciences, especially with Vasayo products. We use only non-GMO phospholipids, and it's really tough working with them, but we're making huge progress. So Dr. Lana Galicia, I'm going to introduce you here for a minute, and then I want you to train us a little bit about what phospholipids are and how they're used in liposome technology. But so Lana is the Chief Medical Officer at Aroa Vista Pain Clinic in Moorpark, California. We love hearing her speak. She's always a great presence on stage, always smiling and everything. She's trained as an anesthesiologist, and she's going to tell us a little bit about phospholipids here. Lana, are you on the call?
Hello, good evening, everybody. Blessings to everyone. With this new direction and employment of liposome science, in part due to the low absorption and bioavailability rates of the traditional oral dietary and nutritional tablets and capsules, the low oral bioavailability and absorption of many nutrients is clinically well documented. Therefore, the natural encapsulation of these lipophilic and hydrophilic nutrients within liposomes has made for a very effective method of bypassing the destructive elements of the gastric system and aiding the encapsulated nutrients to be delivered to the cells and the tissues. This is really very important, and one thing that we tend to forget when we present the delivery system that we have in Vasayo, which is the liposomal delivery system, is the value of phospholipids. As you very well know, phospholipid in itself plays a critical role in the growth, maturing, and functioning of all cells. They are the central building blocks of all cell membranes. Even the tiniest cell in the human body contains phospholipids and constantly needs more. Soy lecithin is a complex mixture of phospholipids, triglycerides, and carbohydrates. Lecithin is another one that contains choline, which is an important precursor for many biochemical functions. An example for each, choline helps provide structure and fluidity in cell membranes. Choline improves transfer of nerve impulses to the brain and circulatory system. And choline aids in lipid and cholesterol transport and metabolism. So that's the one thing that we tend to forget, apart from this bubble that helps transmit and transmit these vital nutrients within the cell walls. Phospholipid in itself has vital, critical role in the function of our products. Apart from that, I would like to emphasize what Tracy just mentioned about the kind of phospholipid that we use in our products. It's a high-quality liposomal supplement, and it's non-GMO. Now, I want to emphasize about that. What is non-GMO? That's basically, it means non-genetically modified organism or products. And that's very important to emphasize in terms of our product with Vasayo. There are a lot of GMO or genetically modified phospholipid out there. And I just want to emphasize this. In genetic modification or engineering of food plants, scientists remove one or more genes from the DNA of another organism. And by altering it, by adding these new genes, genetic engineers hope that plant will express the traits associated with the genes. And so it is pretty a potentially dangerous technology if we use the genetically modified or engineered phospholipid. But that's not what we have with Vasayo products. We have a non-genetically modified, high-quality liposomal phospholipid. So in order to make strong, stable liposomes that can encapsulate nutrients and not break apart too easily, it is important to use phospholipids from highly refined sources that have a natural mix of phospholipids, including a high percentage of phosphatidylcholine, or PC, and phosphatidylethanolamine, or PE. Some products are made with low-quality soy lecithin, which does not have the proper percentage of these products to make liposomes. This type of lecithin is typically used as a food additive and should not be used in liposomal supplements. What we have in Vasayo products is high quality. We have found that the phospholipid extracted from non-GMO soy lecithin works the best for high-quality, affordable liposomal supplements. And a very high intake of unrefined soy ingested as food may contain tiny amounts of undesirable substances. But I have to let you know that the intake of highly refined and purified phospholipids derived from soy lecithin does not pose risk. In fact, they have not found, any evidence of anyone being harmed by the regular intake of phospholipids extracted from non-GMO soy lecithin. And some manufacturers actually use a high-quality non-GMO sunflower lecithin too. It is also critical that liposomal supplements must have at least an equal ratio of phospholipids to key nutrients. And by analyzing many commercial and homemade products, it was found that most of them are poor quality. Some are actually merely emulsions. This means that the nutrients are simply mixed with small amounts of low-quality phospholipids or lecithin, and there are very, very few liposome in it, if any at all. One indicator of an emulsion is the amount of phospholipids or lecithin in the product. So for proper liposome encapsulation, you must have at least an equal amount of phospholipids and nutrients. And that's what we have with Vasayo products. With our products too, it is protected from oxygen. Liposomes are a natural fit for water-soluble nutrients that are not otherwise bioavailable. But the process of making stable, quality liposomes is very tricky, as you have mentioned a while ago. Liposomes are sensitive to factors such as heat and oxygen, and the inherent stability, and in some cases instability, of the phospholipids and its nutrients also play an important role in the overall stability of these liposomal products. Getting all of these things exactly right and assuring the liposomes and nutrients remain stable throughout the products is the key to shelf life. And we have that in our Vasayo products. One thing, too, that I really would like to emphasize is that one way to enhance the stability of the liposomal product is through unidose packaging. Many of the liposomal products that have been analyzed are stored in jars, plastic bottles, or even capsules within bottles. Opening the bottle to remove the product exposes the remaining product to heat, light, and oxygen, and this can be detrimental to the liposomes and can cause rapid degradations of the nutrients. What we have are unidose packaging, which protects the product from oxygen until moments before it's consumed, keeping it safe and effective throughout the shelf life of the product. And the bottom line for this, there are many liposomal supplements from which to choose. Some are effective, but many are not. The key is finding the liposomal supplement and the non-GMO, high-quality liposomal supplement that works best for you and from a company that you can trust, and that's what Vasayo is all about. And just in passing about GMO and non-GMO, if we use, see how special our product is, or our products are, because of the non-GMO phospholipid. If these are just GMO, and there's a lot of them, the GMO or genetically modified or engineered plant products out there, it is in fact a radical technology. It is potentially dangerous, and in fact there's a lot of science out there that have shown that these GMO or genetically modified products that can actually alter blood chemistry. It can damage organs and even cause potential effects in multiple organ systems. There have been cases of impaired male fertility. It has shown severe stomach inflammation, with use. It can actually cause intestinal changes. It can cause toxins that can be found and transmitted, especially if the users or the users are pregnant. It can cause harmful effects on aquatic insects, and even can cause hardship on our farmers. So these are the things that we need to emphasize amongst all the users of our products, that we have something that is very special out there. It is based on science, and like what Tracy said, I'm a purist myself. And that's what's critical about the Vasayo products. And thank you for listening, and have a fantastic evening.
Hey, thank you, Lana, for that information. You were great, as usual. Hey, it's really my pleasure right now to introduce the newest scientific advisor to the Vasayo Advisory Board. His name is Dr. Timothy Snyder. I'm going to give you just a brief bio on them, and then, Tim, if you're listening, go ahead and introduce yourself a little bit more. If I missed anything, you've got many awards and achievements, and if any listeners haven't been on to the Vasayo website recently, you can go to the Vasayo website and go to our brand and scroll down to the Scientific Advisory Board, and you can read all about Dr. Timothy Snyder here. He is currently the medical director at the Snyder Eye and Wellness Center in Jacksonville Beach, Florida. He completed his residency in ophthalmology at the Wilmer Eye Institute, which is part of Johns Hopkins Hospital in Baltimore, Maryland. And he's received numerous awards, and I could read a few of them here for you. You know, he's received the Centurion Award for LASIK Excellence, the American Academy of Ophthalmology Achievement Award, the Paul Harris Fellow Award. He's just a great guy to talk to, and I give him all a big welcome. He's going to tell us a little bit more about the clinical studies involving liposome technology and their current use and things like that. Just to wrap this up with a bang, I want people to know how amazing the liposome technology is and what it can do for our industry. So Dr. Snyder, are you on? Dr. Snyder, are you available? Do you need to unmute your phone?
How's that? Better?
Oh, yep. Now we can hear you. Great to have you.
All right, great. Thank you. Thank you for having me, Tracy. Tracy, as I've been listening, I think I figured out why you invited me.
Why is that? Yeah, why is that?
Well, we've got a great New York accent. We've got a great Oklahoma accent. And Dr. Lana, I'm not sure what accent you have, but I guess it's a California accent. And so you needed a Minnesota accent. Yeah. So anyway, if we have a diversity of accents, I think that's great. And thank you, Tracy, for inviting me to speak about phytonutrients. And this is a little bit of truth. As I was sitting here, I was thinking, I enjoy wine and I enjoy drinking it, and now I sort of get to talk about wine. And the reason I say that is Lana so beautifully described the bottle. And the bottle is really the liposome. The liposome. Wine has to be contained in something which is going to do a good job of carrying it, storing it, and allowing it to not spoil. And now I get to talk about wine. And so what I'm really going to be talking about are phytonutrients. But before I do that, I'm going to talk a little bit about how I ended up here. And, I had two of my good friends, Pete and Cindy Jacob, invite me. And that's how it all begins. They're trusted friends. We have known each other forever. They are dear friends. And when they started talking about curcumin and melatonin, two of my favorite molecules, I really knew that with the liposomal technology, this is something I wanted to learn about. And then I was a little disgruntled with medicine, and I think most of us would agree that medicine has not focused on nutrition. I think that if we look at medicine as a whole, we're all pretty aware that the keys to health are, number one, nutrition, number two, exercise, sleep, and weight control. If we can do those things, we really can potentiate much healthier and happier lives. And so that's one of the reasons why I got interested in the supplement industry to begin with. And Tracy, after listening to one of your webinars, you talked a little bit about vitamins, how they're vital amines, really, which means they are vital to life, but there aren't a lot of vitamins. In other words, there aren't a lot of chemicals that are required in order for us to live. But polyphenols really are interesting because polyphenols technically are not required for life, but yet they are required to give us health. And that's really where we are. This is where we come in. And I'm going to talk a little bit about where does Vasayo fit into this market. And it is a market because we've got Tracy, we've got the Scientific Advisory Board, we've got Dallin, we've got Daniel. But really, I think what we're trying to do is bring something which is going to enhance the lives and the health and to potentiate everything from feeling good to thinking clearly to being better parents to being better spouses. And really the way we do that is by potentiating what God has already made. And really what that is we have sort of missed it when it comes to how do we get what God naturally intended. In other words, what we bathe our DNA in is how we end up. In other words, if we bathe it with the things that are wrong, with cigarette smoke or processed foods, that DNA just does not want to perform. And think of it a little bit of like a symphony. If you're trying to play Beethoven's Ninth Symphony, but all you got is a timpani and a piccolo, it won't work. And think of that like all I've got is vitamin E and vitamin C. In the olden days, we thought that was enough, but now we know that phytonutrients really are key. And I'm going to talk a little bit about what a phytonutrient is. And a phytonutrient is actually something that is produced by plants. And a lot of the very, very best phytonutrients are produced right around the equator. And phytonutrients are actually protective chemicals that actually protect the plant from ultraviolet radiation, pests, and other things. And really, they are scavengers of free radicals. That's why they're good for us. And it is pretty well known now that there is an inverse correlation between how much polyphenols we eat and the risk of major diseases. In other words, I can decrease my chance of cancer, my chance of heart disease, type 2 diabetes, and neurodegenerative disorders if I eat enough polyphenols. And a study was done in 2007 which showed that if you eat 189 milligrams of flavonoids, which is one of the major polyphenols, there is a direct association with a decreased risk of cardiovascular death. So we've got it. But how many people know that? So you have to eat plants, you have to eat polyphenols in order to decrease your chances of living a long life, or at least not dying from cardiovascular disease. And there was another interesting study that was done, and it was a Hungarian study that was completed, and it showed that the average child in Budapest, Hungary, only ate 19.5 milligrams of flavonoids a day. The average adult ate 18.8. Now, I just recommended that our total daily flavonoid intake should be 189, and it was very rare for that amount to be taken in. In fact, children, the range was from 0 to 179. That means there were some children that never had any polyphenols. They had 0 flavonoids in their diet. That means they were eating macaroni and cheese or processed foods, something which was not plant-based. And we know that we can survive without plants in our diet. We know that. But it's hard to live a healthy life. And that's one of the reasons why Americans have so much disease, because of what I said. It's diabetes-related, cancer-related, cardiovascular disease-related. And those are really the killer of American society. Now, it's interesting that an apple has over 800 phytonutrients in it, and right now there have been about 8,000 polyphenols which have already been identified. And flavonoids, like we talked about, are the most common and the most important group. But it's also interesting, and we've talked about this in the past if you've listened to some of the webinars, that our food today does not have as much nutrition as it used to, because the flavonoids are based on how was it stored, how was that apple stored, how was it processed, was it ripe when it was picked, what was the soil content when that apple was grown. So there are so many variables that go into whether or not we're going to get enough flavonoids, which are going to keep us keep us healthy. So that sort of gets us to, how does this fit? In other words, how does this fit? How am I going to get that wine into the bottle? And it's interesting because if you look at what really is keeping us healthy, it is flavonoids. But this is the problem. Flavonoids don't really go easily from our stomachs into our bloodstream. In other words, they are not very water soluble. They're very fat soluble. So we have to find a mechanism where we can allow the polyphenol to go across our gut and get into the bloodstream. And that's really where the phospholipid comes in, and especially the nanotechnology, which Tracy has mastered. One of the interesting things about curcumin, and curcumin, as I talked about, is one of my favorite molecules. The reason that it's so fascinating is because it's not much that curcumin, which is the turmeric spice, can't do. And as you know, curcumin is one of the major ingredients in the Renew product. But if you take curcumin and eat it, it really is not very well absorbed. In fact, it never has been. But if you take it and put it into a phospholipid nanoparticle, you can increase the absorption by 26 times. Now that's important. That means that you get 26 times more concentration of this particular chemical, which is a polyphenol, which is curcumin, in your bloodstream if you put it in one of these nanoparticles that Lana talked about. And what does that do? First of all, it allows it to get into the bloodstream where it needs to live. Not only that, but it also allows for it to stay in our bloodstream 4 times longer. Not only that, but it actually also allows for that curcumin or polyphenol to get to the end organ, which means it's not going to get metabolized until it gets to where it needs to do its work. So the technology of the nanoparticle or the liposome is incredible, and it's really critical to the success of things like Renew, which is one of my favorite products. Tracy, I'm going to sort of finish up a little bit here, just to say a little bit about why I think that Vasayo is such an amazing opportunity for all of those of you that are listening. Who will bring this technology to the market? And that's really my question. You know, if you look at what these polyphenols are, they're required. They are so critically important, but doctors are not talking about it. Nurses aren't talking about it. So I think that Vasayo needs to take it upon themselves, which they have, to somehow inject themselves into the equation of making Americans and the world a healthier place. Pharma is not interested because we can't really take a plant that God produced and somehow put a patent on it. And medicine's not really that interested, although I'd like to think we are, but there's no revenue stream if we keep all of our patients healthy. So this is sort of the beauty of Vasayo. If you take capitalism and mix it with altruism, that's really what Vasayo is. It allows us to have a venue where we can make our world healthier, but we also have a means of allowing us to improve our standing in life and to help our families and to help others as well. That's why I'm proud to be associated with Vasayo. And Tracy, this symphony of bathing all of these micronutrients in our DNA, I'm proud to say you are the maestro. So thanks for having me, everyone. It's great to be on board.
Hey, thank you, Tim. That was great. And I'm super glad that you talked heavily on polyphenols. Like I said today, I spent most of the day in the lab today working on a liposome encapsulation of a new category of polyphenols that nobody's ever heard of. I'm not going to let the cat out of the bag. You're just going to have to register for convention in August. But that's what I've been doing, what we've been working so hard for. There is a brand new category of polyphenols that has amazing clinical research and clinical studies on everything from, well, you know, I'm not going to say because that might let the cat out of the bag. Anyway, a slew of clinical studies on this stuff. It's amazing, but it's a very large molecule and it's very hard to encapsulate, and we're having to run batches over and over and over again to try to get it stable in a liposome. And you know, it's going to be another day or two full-time in the lab probably, but we're so close to getting this done and presented to you for August. So Polyphenols really are the key to ultimate health. Again, thousands of classifications, very hard for the body to absorb and assimilate, and that's where liposome technology comes in. 2 years ago when Dallin asked me, hey, what's the trend? What's a way we can truly help 1 million people? Where can I take this company? What can be the story? And he asked me that, and I told him, I said, Dallin, it's liposome technology. Nanotechnology really is the future of the nutraceutical industry, and it's not just that. You're going to see it in everything. You're going to see nano-infused clothing in the future. You already see nano-encapsulation of certain metals in the metallurgy industry, making our laptops stronger, making our vehicles stronger. You're seeing liposome and nanotechnology in the painting industry. They're nano-encapsulating paint and color molecules so that you can get an even spread of paint with one coating instead of multiple coatings. It is the future, you guys, of science, not just for the nutraceutical industry. Vasayo has set itself up as the leader in delivering liposome technology to the world, bringing these new polyphenols, new nutrients, clinically proven, validated phytochemicals that are traditionally hard for your body to absorb or poorly absorbed, as Dr. Sabo said in the beginning, and now presenting them to you in a format where they can do good and benefit to your body. And that's what Vasayo is all about. It's about changing 1 million lives, one person at a time. You should read the testimonials we get on our website and to my inbox and to the customer service department. We really are changing people's lives every day and doing it with this amazing technology that we've learned a lot about today. I want to thank Dr. Sabo, Dr. Iglesias, Dr. Baker, Dr. Snyder. Thanks for your time and your preparation on this call today. Everyone, we hope you have a wonderful night, and I look forward to seeing you at August Convention in Salt Lake City. Have a good evening.